Hello everybody. Thanks for joining us here in Seattle. I know it's the end of the conference. Just a quick note, this was supposed to be an hour and a half workshop, but there was some issues with the schedule, so we only have just over an hour. It means I have to rush a few things. But anyway, my name is Toine Siebelink. Should have started probably with that, and with me here is Anjella Macabuhay. We work for Ericsson Software Technology in the CPS project in ONAP. CPS is close to achieving gold standard. So that's really what this talk is about. I want to share with you how we achieve the gold standard, specifically the code coverage, which is a problem for many teams to get the kind of code coverage that you need for gold standard. I think the limit for gold is 80%. In CPS, we're at 97%. We had a bit of an advantage because we're a green field and we built it in from the beginning. So that's the first tip there to achieve it. If you're a greenfield project, build in test from the very beginning. Since the workshop, keep any technical questions for the workshop part. We have published a demo project. I don't know if there's anybody here, or maybe you still have another 10 minutes if you want to download it and work with us on some of the exercises. Okay. Just remind people of the purposes of unit test. So first of all, unit test, of course, is about validation, prove what the code does. Then secondly, assurance. So we want to make sure that when we modify our code, that we don't break any pre-existing behavior, so preventing regression. It can be helpful for test or factor in, be used in test-driven design, behavior-driven development, of course, where you can, especially when you're working on a complex algorithm, if you develop the test at the same time or write your test first even, then it can speed things up. But in general, I would recommend to, no matter what methodology you use, always deliver your production code with test to accompany it. Of course, when you want to achieve the kind of percentage we had, you kind of have to do that. Finally, but not least, unit tests I think are very important for documentation. It describes the behavior of your production code. Production code can be sometimes hard to read, and having good tests describing that behavior, the happy paths, the edge cases, and also the error scenarios helps developers understand your code. And especially in an open source environment, I think that's a very important aspect of the unit test in this case. So misunderstandings about unit tests. The unit test is only for code coverage. Yes, unfortunately, we work in, some of us work in big companies where we have managers, and managers like setting goals, managers like telling teams, oh, we need to have so this percentage of code coverage, and then the teams just try to get that percentage, as opposed to really looking at the quality of the reasons for the unit test that I explained in the first slide. So then the emphasis goes wrong. I think it's more important to develop high quality tests than having good code coverage. Unit tests should only test one class at a time. Yes, by definition, that's what a unit test should do. In reality, it's a bit silly if you mock everything. In reality, you can write a test for a bit of business logic and at the same time test the underlying data holders. And just be pragmatic. It's just quicker and easier. Mocking is difficult. I agree. I've been using many different frameworks over the years in Java, and defining mocks or declaring behavior or certain behavior can be quite complicated in most of these frameworks. But that's really one of the great advantages of Spock and Groovy. It made it so much easier, and you see that during the workshop. Unit tests are redundant. I have very good integration tests. Absolutely true. Integration tests are important. Sorry, I didn't mean that statement is true. Integration tests are important. You need to have them. They prove that everything works together. But the power of unit tests is that you can test all the variations in a very fast feedback loop. If you put the emphasis on doing that in integration tests, you get a very slow and hard to maintain, usually big kind of suite of tests that become brittle as well. Martin Fowler, in his theory on the testing pyramid, describes it quite well, how you should use your unit test to have a good base, and then you need only little integration tests to kind of prove that things work together well. So why Spock and Groovy? As I said before, I've used many different frameworks over the years, and I think Spock and Groovy is really kind of the combination of the evolution where all these things, the best of all these things come together. One of the big advantages of the language itself is it has a human-readable kind of structure. It's designed to define tests as opposed to JUnit, where you're using the Java language, which isn't really suited for describing tests in a human-readable way. Spock and Groovy provides different labels. One of them is called where, and that helps you in a very easy and intuitive way. You can modify your test to test the test with different parameters and expect different results. And again, during the workshop, we touched on that, and it's really easy to do in Spock and Groovy. Something I call Groovy Magic. I don't know if people have used the Groovy language before. It's a standalone language, but it gives you a lot of things. You can do things easier in Groovy than in Java. For instance, defining collections and maps. You can. It's a very compact, intuitive way of defining them. Also, Groovy gives you access to private members of class, and specifically for testing, that can be useful. And I'll show you in a bit more detail later how you use that. And then finally, as I mentioned before, the whole definition of mocks, setting up your mocks, your behavior, spies, and stubs is so much easier than ever before. Okay, here a traditional JUnit test. So typically the developer has tried to put the name of the test, what the test is doing, in the method name. But of course they can't put in spaces. And they might have used comments to define the different steps. Now in Spock and Groovy, there's no need for that anymore. You can just define a method name in a plain English sentence using spaces. And you have the when and then blocks or labels that you can break down the test in, and you can add description to those as well. If you run the test and you get something like that, this is from an IntelliJ. There are also tools out there that provide detailed reports with all the different steps in a very readable way. So this is for your non-developer, maybe those managers were looking for the quality. Instead, they should be looking at, okay, what are we actually testing here? And again, they can read it very easily what's being tested. So to go in a little bit more details in all the blocks that the Spock language provides. You start typically with given or setup to define some parameters, or maybe define your mocks or your behavior. They're optional. Sometimes you can go straight to the when block, which is where you run the method that you're testing. And then, as the name says, is used to assert what had happened during what you executed. For simple tests, and in the workshop we'll show an example of this, you can also run a method and at the same time tries its result, but just using the expect keyword. So you don't have to break it down on when then, you can straight say expect. There is a cleanup block. I've actually never used it. It does what it says on the tin, but in reality, good tests run in a clean environment anyway, shouldn't store any states, and you don't really need it. As I said, I've never used it before. Then finally, the where key block is to define the parameters if you want to run your test in several times with different parameters. So here's a short example. So this test defines a quick test using 3 blocks, when and then. So you see the where table there, and I've kind of highlighted there in red. This is the data-driven part. So if you look closely, you see at the top of the where table, you see a header of a table where I define X and Y. And an expected result. The expected result is separated using a double pipe. That's just a kind of convention to separate the input parameters from the output parameters. So X and Y is basically defined here 4 times. So we have 4 rows. So this test is run 4 times. So it substitutes this X and Y in the map power function here, and the expected result is substituted here where I assert the result. So typically you use your where to test edge cases is always what I recommend. So 1 or 2 normal cases and then an edge case, and just make sure you get still the expected results. Also the descriptions. So I always say try to use the descriptions and the labels to make a story so that a human reader can read like when I do this, then this should be the result. Where does it really fit in that? But you can have the idea that basically trying to make it as readable as possible. And again, in the descriptions, you can substitute the parameters and they will be outputted in the report as well. So using this hashtag in front of it. So that's the global structure. Now, remember I mentioned private access that Groovy gives you. Some people that have written JUnit tests, they might have done something like this, and I've done this myself in the past. If you have a dependency that's been injected or whatsoever, you might write, for testing you might need a mock because you can't get a dependency production version of it, or it's just too difficult. Anyway, the point is that you would have to modify your production code to write a specific setter, and you might say that this is set the CPS cache for test, and then the test method or the test here, the admin service test, can call that method with a mock of that particular cache. In Groovy, that's no longer necessary. So here I have a setup block that directly accesses the CPS cache variable, although it's private, and I just assign it to a mock. Now, mocking and invocation checks. So just like all the other frameworks, the Spock provides you with spies, mocks, and stubs. And then to define a mock, in this first example here, you just use the mock keyword with the class name. And then to define the behavior, we use the two greater than symbols. It's called a pipe. I think it's called a right shift pipe to be exact. If the other way it's the left shift pipe. We'll see that in one of the exercises coming up as well. So in this case, I'm defining that if this mock is being called with the method get anchors with this parameter some data space, then I'll output a collection of anchors. You might notice here anchors is defined using Groovy Magic as well, as opposed to plain old Java. You can mix and match them, by the way, but I always prefer to use Groovy as much as possible to make tests more readable. To a certain invocation, to check the interactions with your mocks, you can simply check your, well, you have your class there, your mock, and the method that you're looking for, and you just put one time in front of it. So this more or less says, what I'm asserting here is this method called one times with these specific parameters. So these first two examples use strict parameters, where I say I'm expecting this, or only if this is called with these parameters, it's kind of valid. You can relax that, and also the number one there, you can modify that. So I'm kind of combining making two jumps there in the next one. So in this particular case, I'm saying, well, I don't expect this method being called at all. And typically in that case, you don't really care about the parameters. You just don't want it to be called. And there might be reasons why you want to test that. For instance, you're testing your cache. That's an example where I probably got this from. So you want to make sure that if this was in the cache, that this method is never ever called. And this is the way you would assert that. It is possible to define behavior and asserting it in one, but it's kind of not recommended. There's also more technical reasons why you shouldn't really need it. Anyway, let's move on. Yes, if I had more time, there's loads of other things that are in the Groovy and the Spock features. And I do want to say, and hopefully we have time for a quick demo, that it is easy to combine Spock and Groovy with other existing frameworks you might be familiar with, like Spring Boot tests and test containers. We are using all of those in CPS. So talking about the CPS project, if you're interested in contributing, we're always looking for more contributors. So here's our developer landing page for our, can you see our way of working and how to approach us. There's also links here for the repos. So if you're looking for more examples on the Groovy and the Spock testing, then our repos are definitely an interesting resource to go to. Yeah, I think that brings us to our tutorials. So is there anybody in the room that wants to partake in the actual test? Okay, great. Anjella, if you want to take it. Oh yes, I forgot about the chocolate. Oh, we only have one candidate. For every test that you run successfully, you get a chocolate. So nobody else? No?
Is that clear for everyone? Yeah? Okay. Right, so in the project that we have linked there, we have 5 exercises. The first exercise here, we're going to start with the basic specs. So here we're going to show you what basics of Groovy is. So we just have here a basic class, but to make this test a Groovy specification, we have to make the base class the specification. So we're going to extend to specification. Now that all of our tests now will look just like that. So the first part of this test, I'll show you how we use the when and then block that Toine was talking about earlier. So here the test is to assert that the method mat.max returns the correct value. So if you don't know, the mat.max is just to calculate 2 integers to see which one is the maximum. So we'll go start with the when block. Here we need our method, so when mat.max, and I'll choose 1 and 2 as our integers. When mat.max, and then I'm going to assign that actually to a variable. I'm going to call it a result. Okay, and as you can see, I called def, the keyword def, instead of saying integer or string, because in Groovy you don't actually need to specify that. It already knows what type it expects. So you have when, and then we'll use our then block to assert what the method in when is giving us. So we're going to use the keyword assert. That's a Groovy keyword. So we're going to say result is equals to, and as we know, the maximum between 1 and 2 is 2. Just give it result is equals to 2. And to finalize this test, I'm going to put the labels. And as Toine said earlier, we want to tell like a story and to make it like simple for non-developers as well to understand. So we have when the maximum, I'm just going to like telling a story, maximum between 1 and 2 is calculated. Then the result is 2. As you can see, it's very clear for non-developers, and then it will also be good for like developers that are looking at your code and methods the first time, and they could just look at the test and they would understand how your method works. So go run this test. As we expect, it should give us pass. There you go. Thank you so much. I don't know how to hold this. Well, typing, so, but you can hear me clearly? Oh, okay, perfect. And right, so if we give this a false value for IntelliJ, anyways, and other IDEs, it will show you the difference of what we expect. So here, and to see the difference there, we have expected what we said the result is equals to 3, and what the method has given us. Okay. So for the next exercises, I'm not going to label anymore just because of time. For this next one, I am just going to show you the expect block. Expect block. The expect plus is basically combining our when and then. So I'm going to use the same method that we used earlier. So I'm going to go math.max is equals to, math.max of 1 and 2 is equals to 2. And this should pass. Okay. And we see here that even though I haven't used the keyword assert, it still ran and passed. But actually, we recommend to use the assert keyword just so we can highlight what is actually being asserted. But in Groovy, anything under the then and expect block in Boolean expressions is automatically already being asserted. So you don't actually need the word assert for the then and expect block, but it's good practice to put the assert keyword. Okay, and actually first we can run all the tests in this exercise, and one would fail, and you could see there that it's highlighted which one has passed and which one has failed. Okay, so we move on the data-driven one. Which one?
Any questions on that? Maybe you go check if a member here was able to run it. Bring him a chocolate if you got it. Thanks, Anjella. Okay, so exercise 2 is about the data-driven test. So we continue with our math theme. It's kind of easy to understand. We don't need to show you any production code. So to complete this test here, I want to check that if I raise a number to the power of 0, for the people that are good at their maths, they might remember that anything raised to the power of 0 equals 1. So in this particular case, I just need to complete this code here to check the result. And so this is the left shift pipe I mentioned earlier. In this case, and I always think of it as we're moving whatever is here into X. So I kind of visualize it like that. When I was defining behavior, it was, okay, when this method is being called, this comes out. In this case, these values go in. So I can simply test it with normal values. And I just define basically a collection here of values. But more interestingly, and like again what I said earlier, you might want to test it with your extremes. So maybe we'll test it with max value, make sure it doesn't crash there. Now I'm sure Java developers that actually developed the power function did something like this originally. I'm just showing it here now. Normally you wouldn't really test your 3PPs. This is only for demonstration purposes. So you see now here, I defined 3 values here. So this is a bit different than the table I showed before. This is just with a pipe with a single value. The reason in the example I used the where, and I showed it next, is in reality you almost never have just one single value and always the same result. So let's move on to the next exercise where I show that. So now we have a method here that wants to check the result of, oh, it's going to roll away. So, we're going to have we want to test the max value. We use the max method here again. So we want to define a table in this case. So we just call our variables. You can call them whatever you want, by the way. And I'm going to use expected result here. By the way, I do like and I would recommend use these kind of names in test results, expected, so it just makes it easy to read. And if you use them consistently, it just helps the readability of your test. So we do have same values as in our previous one. And we just define the expected result. Maybe we'll swap them around. And maybe in this case it's interesting to use negative numbers. So -1. No, my formatting doesn't work there. -2. So in this case, -1 should be the higher value of the two. You don't have to align them, it will work. And I'm a little bit OCD when it comes to this kind of stuff. But you can also set up your IDE to do this automatically for you, just to keep things readable. So now I've defined a little table with 3 test cases. Expected result, I presume that was everything that was to this exercise. So let me run it here. No, I have something wrong. Oh yeah, of course. Nobody saw me doing that. I was really testing you there, but no, it wasn't really. That's what I pretend. Anyway, you saw there that if I ran the 3 tests, the test doesn't stop. It just runs all the tests and it reports which one fails and why it fails, etc. I think that's the end of the data-driven exercise. So, Anjella, you want to try the next exercise? How did you get on with that one? Have you got another chocolate? Okay. Oh, you already gave him say 2.
Yeah.
Well done.
Okay, so the next exercise would be on exceptions. So good practice to test how we handle errors and exceptions in our unit tests. So for that case, we are going to use this test to assert that dividing by 0 returns an exception. So when a number is divided by 0, we know that's a no-no. So we will get, in Java, we will get an arithmetic exception. So we'll just go on our then block, that's how we saw earlier. And we are going to say thrown. And that just says that the method that we have in our when block is going to throw this following exception, which will be arithmetic exception. And run that fast. Okay. And I'm just going to show you that it won't accept just any exception for that matter. It'll, if we have a null pointer exception, it'll know exactly that it's not the type of exception it's expecting. Okay. So the next exercise after that is just an extension of this one, wherein we are actually going to check the exception message that comes with the exception thrown, sorry. So we're going to use the same one, we're going to use the same dividing by 0, and we have the same when block that we saw earlier. But in this case, in our then block, we have assigned the thrown exception into a variable called thrown exception. And then we now see here our end block. So our end block then allows us to have another assertion. So we're saying end exception message contains the word 0. So we'll start with our assert keyword, as good practice there. And then we're going to say thrown exception. Now for Java, we would use get message to access the field message for this type, but actually in Groovy, and this is the same for the private fields, we don't need to use our getter our get method, we just go dot message, and then we can check that it contains the word 0, as our label said there. When we run that, I know this passes because the actual message does contain the word 0, but actually we could have used a Boolean expression to say that thrown exception message is equals to whatever exact message that we have, but but in this case, using just the keyword that we have, like an important keyword that we actually just care about for this test, it makes our test less brittle, because then if we change something in the actual message and then we have tested the exact message for this test, then it agrees us on failing the test and breaking the test, which would make the test more high maintenance. And okay?
Yep.
And, right. So I think that's for the exception, and the second one, mocking. For
Yeah, you leave that one to me? Okay.
Yeah.
Thank you, Anjella. Yeah, that last thing is just kind of a strategy. Sometimes you only care about a word in a sentence as opposed to the exact sentence, and yeah, somebody adds the full stop to the error message. You don't want the test to fail because of that. Okay, but let's move on to mocking. So just to show you how easy it is to mock and define behavior, etc. in using Spock. Now this first test here is actually a complete test, but it should fail at the moment. Let me go to the individual test. So there's a setup block here. I didn't mention that, but you can do setup blocks as well for all the tests, just like in other languages. So I'm going to run this first test, just to show that at the moment this test will fail. Oh, apologies, I should really, before I show anything here, I should have shown you the production code. But now you need to know a little bit of the production code. So we have an employee, can be constructed with or without a name. There's two services being used. In this case, it's just plain old Java. In reality, these are typically injected using Spring Framework. But anyway, it doesn't really matter how they're used in the test. They can be overridden in the same way. Just take note that there is an email service and a payroll service used by this employee class. I'll get to the total salary later, but so if I go back to my test, now I have to try to think, probably control this one is probably the easiest way, yep. So this exercise defines the employee, it mocks a payroll service. In the setup, we assign that payroll service to the private variable here, as we explained before. We assign the mock basically. But if I run that now, we'll realize, I ran it before already, it's not enough. We see a null pointer exception. So if we see here, so it gives a null pointer exception here because the email service wasn't defined yet. And apparently when we pay the salary, apart from the payroll service, also the email service is actually, and this is typically how we would build a test. I would just try it out, see how far I get, and then add something and just go back and forth between my production code, if I didn't write it at the same time, that is. So that's what we need, obviously. So now we made the exercise easy by giving you an example above it already. So we just need to kind of follow that example. I'm gonna say, I'm just gonna spoof the name a bit. I like Eclipse name suggestions sometimes. So no, it doesn't suggest. It didn't fix that for me. So the email service, and then if I do, now it should give me a. Email service. No, it's not helping me. Sorry. I thought it would. That's me defining a mock email service. Now that is only defining it, so I now need to insert it in my object on the test. Email service. Oh, by the way, here again you see that Eclipse is not, or IntelliJ is not helping me because it's a private variable. But if you know the name, you can just copy and paste. It's no big deal. So assign it. So that's basically been setup completed. It's the same setup for all the tests, so that's why we did it in a separate setup method. Could have done it in the setup block as well, but then I would have to repeat it for all the tests. We don't want to do that. So there you go. That's that test fixed. Simple enough. But now let's do something with these mocks, because that's what it's all about. I'm going to make that bottom window a bit smaller. So here we have a test that test how the total salary is calculated. And if we actually look at the production code, we see that the total salary is calculated by getting the basic salary for a certain employee plus a bonus. So in the test setup, I've used the given keyword in this case. I define a bonus of 100. I run the method to get the total salary, and then I expect the result to be 4,000 plus 100. I could have typed it full, but I want to show it that some of these two. Again, it's all about readability for me, about test. So obviously to pass this test here, I don't think we'll even compile at the moment because that end keyword is not completed. Anyway, just compile, but obviously the result is now 100 because we haven't defined the salary yet. And that shows something about the default mock behavior. Default mock behavior is to return null for objects, or kind of the zero value for primitives, if you know what I mean. So I need to define the mock behavior. So my mock payroll service, that was the get basic salary method. Now, at the moment, I don't really know or care about the employee name, so I'm just going to use the underscore wildcard, and I use my right shift pipe to define the output. I never think right pipe, I just visualize it in my head that this is what comes out of it. So what comes out of it is 4,000, and if I run the test now, we should see that the test passes. So now we've defined the mock behavior. In this case, I've done it relaxed, as I call it, or not strict. So we can put in the, what was the name of the employee again?
Sample.
Sample, thank you. Mr. Sample or Mrs. Sample employee. So if I put the name in there, now I have you won't see a difference, but now I have a more strict test. Typically, I would recommend strict tests. So you expect certain parameters, because parameters could be, maybe for instance, it was doing a lowercase and it was expecting a lowercase of the name for specific reasons. So I would recommend these kind of strict tests for this kind of scenarios. If I change the name, just made a little typo there. So now I've defined to get the base salary for, oops, oh, it's back. I think I stepped on something. So if the name is incorrect or if defined for another employee, then this employee doesn't get the 4,000 salary, so the test fails with the same result as before, that it's only 100. So we got 100. So let me just fix that back to the sample employee. Anyway, that's just on defining behavior. Then finally, no, not finally actually, there's one more after this. We want to check invocation. So the previous example, the outcome was dependent on some previous, where I defined the output of my mock. Now sometimes there is no output, like a void method. So for instance, the email service just sends an email and doesn't send anything back. Now, but I want to know that the email was sent. So in this case, I want to check invocation. So I'm interested in my mock email service. Send email. Again, I'm not going to care about the name in the first instance. I actually won't change it. You kind of expect what happens. What I will do here is, so I'm saying one time. So I expect this method to be called one time. So this is very useful, and often if you're just checking delegation or you don't really care about this other service, but you want to make sure that the chain is there and the events happen, that's basically all you do. Just, and it's very readable. One time, this method. If expected to be called twice, actually, no, I'll do something else. I think you can guess what happens when it will say it's only evoked once. But maybe I expect it to be called for another employee. And now Spock is, I just want to show you a bit of kind of the cleverness of Spock, which is kind of useful when you're coding this kind of stuff. It will say the test has failed, of course, I expected that, but it's telling me exactly why. Or no, more instantly, it's telling me it found another invocation to this mock which looked very similar. So basically it tries to match any existing invocations, and it tells you, well, actually I found this invocation, but that was for a sample employee, and it tells you exactly what the difference is. There are 6%, well, I don't care. I say, okay, all right, okay, yeah, I got the, sorry, maybe I passed in the wrong parameter. It's a more realistic case. So in this case, but basically, yeah, that's the point. It will tell you and will help you finding the correct parameters, and you can just use that when you're building your test to build them up like that and make them more strict and get them exactly right. These are all very convoluted, very simple examples. In reality, you'll be the more complex stuff, and that kind of similarity matching really helps there. Okay, so one more exercise on, because the screen is a bit, I hope it stays active now. Yes, I wanted to show you something about, so if we go to the total salary method here, we have a so-called fired employee exception. Maybe it was somebody that worked for Twitter recently. So the payroll service can throw a fired employee exception. And basically the total salary just ignores that and just says, okay, if that's the case, maybe this is completely automated, all I do is send 0 and make sure that that employee doesn't get paid anything. So that's the behavior I want to check. And this can be quite tricky in normal, or especially if you have real instance. So how do we add that using mocks? That's what I want to show you here. So let me go to the right line. So in this case, my mock payroll service, the method get basic salary. Again, I don't care, and this is typically where I never would care. So because I want to just accept my exception handling. So what does it do when this method, instead of returning something, I can say, okay, run this bit of code using a closure. That's what it's called in Groovy. Just those two. It's like a mini method. Throw, if only I could spell properly. Throw new. What did I say? Fired employee exception, yeah? So there we go. So now when this method is called, I'm making the mock throw an exception, and I can assert what I'm expecting, that the total salary on that is, and by the way, I'm using a field again instead of a method name. Again, in Groovy they're just interchangeable, and for readability I prefer the fields, or the not, but kind of not getting misled by get and set. It's all kind of nonsense anyway. Okay, so that's ran that test, and because it threw a fired exception, the total salary was 0. I think that completes the testing on mocking. Any questions on mocking? Okay. How are we doing for time? We're not doing too bad, I see. So maybe we'll switch back to, have you got the CPS project loaded here? When we show the, yeah. And then maybe we do the Groovy Magic as well. I just want to show off here, you know, how it comes together and the kind of test. Because I can imagine that looks all quite simple, but when you combine it with other technologies, that's where it really comes really powerful. This is the
Data persistence?
No, that's the normal one. You need the integration one. Yeah, thanks. Yeah, perfect. Yeah, what happened there was actually what we do is for these tests, it's kind of interesting. So this is our test, this is in our data integration area. This is where we work with the SQL database. And we kind of have two types of tests there, because in the SQL we pass around SQL queries. And yes, we could just mock and see that the right query is sent to the database. But then we have to write separate database tests, and that's kind of a bit awkward. So in this case, we use a test container. So we're using a Docker container with a real instance of SQL. And I'll just show you how that kind of works. So these tests all extend this spec base, which extend, so yeah, that's the spec base. Then we use these answers. It's using two standard Spring kind of frameworks. This test containers is from itself actually. I looked it up. It's just a website called Test Containers. There's no particular company or anything behind it. It's very powerful anyway. And it's the Spring Boot test as well to make everything, to make the injection work and all that kind of stuff. But there's still a Groovy-Spock test, just using these standard annotations. So we have a database test container here. So if I go here, I'll probably, that is our code, yeah. So this is just defining a test container, and I think if I scroll up here, you can see, yeah, so it's just defining the image version. So this is inserting my, my Postgres SQL, and if I go back to the test itself, basically you see things like, if I scroll down a little bit, yeah, there we have one. So we have the SQL annotation. These are just constants that point to files. So we have a file to clear the data. As I said, it's important. Probably could have done that in in a cleanup block as well, but here it's built into the framework to do it as part of this annotation, to clear the data first and then add some data. Then it runs some tests, so you recognize all of this, when, then, and can go anywhere. It can be, you can have when, when end, but typically the setup and then is when you use the end a couple of times. Anyway, this is combining all of this together, and I'll go back to the normal view. Alt-P, wasn't it, or Control-P? Which one did we define? Alt-P. That doesn't work at the moment for some reason. Let me try again. No. What's that thing? Is that just we had set up a macro to switch between the presentation view and the normal view, because I just want to show you the whole project layout here. So, and just to mention again, this was an integration stack. At the same time, we have a one that is an integration test, and that's why we have the error handling. So we pretend that SQL throws an exception, and we make sure that, and then we use a mocks, and we make sure that the exception is handled correctly. So I can right-click here and run all of these tests in one go. Hopefully, if we did run it before, it's a bit faster. Yeah. So starting the container there, starting Spring Boot. Takes a few seconds to do that. And most of you know, as long as you have a machine with plenty of memory, this stuff is fast. If you have a machine with not enough memory, then you might be sitting here waiting a couple of minutes. It's going to run 180 tests, if I remember correctly, and you can see there the speed of the test. So these are, I call them semi-integration tests, because we're really using two different layers here. We're using the Excel database and our Java code, and we see how they interact. But they're not full integration tests. I think I would more rather class them as unit tests, because they are fast and you can run them immediately. The developer gets the immediate feedback, and it's very powerful, as you can see. So that's kind of a quick run there of how it all comes together. So maybe if we have time, you want to show the Groovy Magic. Show us some magic.
Okay, go on test. That would be exercise 5. Okay, so here we are going to look at lists, maps, and constructor in Groovy, the Groovy way. So it will be on exercise 5. The first exercise there would be on Groovy list. So you can see here that the code is already done. We just need to add 2 lines of code. So it says here, complete the task below to define list of numbers. And for Groovy, we actually saw this before already, we can just use the keyword def, and then I'll add list of numbers. We don't need
I'm just going to pick up the microphone. It's picking up where you're typing, and I'll just hold it here.
We don't need to define that it's an array list or so. So we just go list of numbers, and then we use the square brackets. We go, I'll add 2 numbers there, 1 and 2. And then it says when a new number is added, the Groovy way. We're going to have list of numbers. And there's a hint here that says we use the Groovy way with the left shift 5. And I don't know if you mentioned earlier that it just visually is like going in the list of numbers. We're going to add number 3. And then that's completing the test there. So it says then size of list sorted to 3 and all items are greater than 0. So here on this end block, we are seeing that we can iterate on the lists here, and using a closure, we're asserting that each of the items there are greater than 0. This one. Do you have anything to add to that?
Oh, that's good. Yeah.
Okay, so next would be Groovy maps. Same way, we have to comment this thing out. And there's actually just one line of code that we need to add here. And it says complete the code below to assert key C and value the Groovy way. Right, so we have a map here already defined, and the same way we just use the keyword def, very easy. And we have a key value pair here, and you can see here for just a single character string, we don't need to use a single quote, but we can also mix that with a string with spaces, and then we need to use the single quote. So then when retain only A and C, so that means that we're just keeping A and C, then our map will be reduced down to the size of 2, as here we're asserting that. And key A is still present and the value is correct. So this is the Java way of checking when, or we're getting A and checking that it's equals to 1. But the Groovy way, we have seen this earlier as well. We'll just go my map and dot C is equals to 3. So again, we don't need to use the get method, and that's a very nice thing to do with Groovy. And it makes the code very readable as well. Okay. And last but not least is Groovy constructors. Okay. So Groovy constructors, if we go back to the employee, the production code, so we have, oh, what did I do there? Go force and employee. We see that we have two constructors here. One is the non-parameter one, and one where we put name in, create an employee. But here we are told to create a new employee with a bonus. So that means in Groovy we can actually override what constructors we have. So we can go def employee is equals to new employee, and then using a map we're gonna go bonus, and same time there we're gonna define what bonus we have. We have 100 to make this test pass. And run that. And asserting that employee.bonus that we have made is equals to 100. Easy.
So it's kind of combining the Groovy map there with the constructor and override a private variable, all of this at the same time. So that's why we call it magic. You can do all these things that you can't really do in Java, and definitely not so easy, and still very readable.
Anything more to add there?
Any question on that? How did you get on with that test? Running?
Today, all working, yeah.
Oh, he deserves more chocolates. Okay, I'll just show you the conclusion for a minute. Just switch back to the presentation. Is it Shift F5? Oh no, it's switching now. Yeah, okay. Oh, I think this has started again. Apologies, I need to switch back. Okay, so using these technologies in the CPS project, we have 90% coverage, and that's of the SonarQube definition. If you drill down in coverage, it's actually about line coverage and branch coverage, and a lot of people forget about the branch coverage. You always need to test your negative scenario, even if you don't have code there. It's kind of important for, because that's typically where the bugs happens, you know, and SonarQube actually adds extra weight to the branch coverage. So in our project anyway, we're well above, and we have very good, yeah, as you can see, you can't, well, you could get higher, but it gets a bit messy, and sometimes it's not worth it, the little things that you can't cover, typically setup codes and things like that. As I mentioned at the very start, so it's well over the goal for OpenSSF Gold Standard. It gives us, and I really feel that personally, you know, I make some changes, I really have faith in it. I run my unit test, and it's usually a deployment issue why your integration doesn't work. It has nothing to do with your production code. So having this kind of level of unit test, typically you don't worry about your integration test. You know, you run your unit test, you don't care, you move on to your next job. So that's the high confidence level. and minimal integration tests. So we don't have, and this goes back to these scenarios, and I explained it, I try to do it in a diagram at some stage when explaining this as well. If you have 3 classes that all have 4 paths, right, it's very easy in unit test to test all those 4 paths separately. If you do it at an integration test level and these 3 come after each other, you have 4 times 4 times 4 scenarios, and you would have to write them all to cover all those scenarios. It's really the wrong approach. In the integration test, you just copy the happy path, and all the other paths you test them in all the other variations you test them in the unit test. Some tips: make sure the unit test is part of your definition of done. You know, if that's your way of working, then you stay at If you have a legacy project, your base is not so good. If you start doing it now, your coverage will slowly increase. And another thing to do is make sure that your unit test or your code coverage is part of your gating in SonarQube, for instance. So SonarQube can make sure, and it can say only for new code. So you say something for new code, you should have 90% code coverage, and that makes sure that people will continue writing the test. If you don't do that, it tends to slip and it goes away, and people don't write the tests where they're difficult to write. That's kind of what tends to happen. But if you follow those tips then and you use these frameworks and you have a few standard tests, it's actually very easy to use. Another thing, and I remember working with a person that's very much about code quality. He actually said, and I kind of agree, the quality of your testware is almost more important than the quality of your production code. Because your production code gets tested by your testware, but how good is your testware? Like you can write crap testware and get good coverage, but it doesn't prove anything. So reviewing the actual test code is maybe even more important than reviewing the production code, because that proves what the code does. Okay, I think that's it. Loads of reference material there if you want to delve into it. Again, our own project you can use as a reference as well. More questions, but I think we'll cover the questions unless there's anything else. Then I thank you for your attention and have a good evening. Thank you.